We're talking about an ice core. It's a core of ice. It's the story that's told around this core of ice that affects us. And the story that we hear, this idea of millions of years, affects our understanding of where we came from. Why am I here? What's my purpose in life? The secular interpretation is giving the wrong ages, but from a biblical perspective, where does the ice accumulation begin? It begins after Noah's flood.
So if people are thinking, what I originally thought about these long ages, maybe that's not right, what advice would you give to these people? For many people, the concept of ice cores is quite a problem. They think that the evidence points towards hundreds of thousands of years and that contradicts what the Bible says about the history of the Earth. Tas, you're a geologist and you don't think this is the case. You've got a PhD in engineering and an honours degree in earth science, and you've studied the age of the Earth and geology for quite some time. So tell us a little bit about ice cores.
Well, Michael, ice cores, from the perspective that you're talking, they're very controversial. And because of what you said, they go against the biblical age of the Earth. But from an engineering point of view, I think ice cores are really cool in that they are bored into the ice. They go for 3,000 meters into the ice until they reach the bedrock. And an ice core, it's got a drill which is hollow. It's like a tube, and the ice core itself is a tube. And it comes as the drill goes down, it pushes the ice up into the tube and recovers it, and you'll get this long core. Of course, you can't handle a core that's 3,000 meters long, so when it comes up out of the ground, they break it off into 1 meter lengths and they pack it away. Eventually, it's stored in a really, really cold place. So they eventually take it out and they analyze it and make all sorts of measurements on it. So that's what an ice core is, and it's a really, really interesting engineering project.
Yeah, I'm still trying to wrap my head around 3 kilometres worth of ice core.
Mm.
Now, that's a lot. I can see why they split it up. So can you tell us a little bit more about how many ice cores have been extracted?
Well, probably less than 10, maybe only half a dozen different really big projects. Some of the earliest ones, there were 2 which were done in Greenland, GRISP, and they're given little names like that. One was by the Americans, it's in the 1989s, 1990s, something like that. And that was 3,000 meters long. And there was one by the Europeans as well. And that was similar sort of length at about the same time. And so they were in the news and created a lot of interest, particularly sort of the idea of understanding what are they telling us about the Earth and about how we got here and all those sorts of things. So that's why ice cores are very, very significant.
So you mentioned 2 in Greenland. Are there ice cores in other places as well?
Yes, there's quite a few in Antarctica. And it's very interesting. There's one that stood out to me. It's by an Australian consortium. And it's called the Million Year Ice Core Project. It's called the Dome Sea Project. And I thought that was really interesting because they've already know how old the thing is, and they haven't even drilled it yet. And they haven't counted any layers yet. So it's the Million Year Project. And I think that says a lot about the mindset of where they're coming from.
Yeah. So I suppose that they're assuming that they can count the layers once they do get the ice cores and see how long it is. Is that the case?
Yes, well, in some cases it is, and in some cases it's not. In the case of the Greenland ice cores, the layers on the top can be counted, and they get narrower and narrower as you go down until eventually you can't actually count the layers. They're not as clear as to being able to count. In the case of the Antarctic ice cores, the snowfall, the accumulation of the ice is so slow that it doesn't have layers. So there's no layers at all to count there in Antarctica. If there's no layers, you can sort of make it whatever age you like, and we'll find out a little bit about how they do that.
Okay. So if they've got low accumulation rates with the layers, what if the accumulation rates are higher? Can you count it in that case?
Yes, they do. In Greenland, they count the layers at the top of the ice cores there. And it's interesting, of course, so because you can count the layers, you can make observations. And when we're talking about science and you can make observations, doesn't matter who you are, is that you agree on the observations and you come up with the same story. And that's the case, particularly for the top 1,000 meters of core in Greenland. The uniformitarians and the creationists basically come up with very, very similar answers. There's not much deviation of the uniformitarian ages that they quote from the creationist ones.
Before we continue, a quick heads up. Stick around until the end of the interview because we'll be offering an exclusive free ebook, The Creation Answers Book, packed with biblical answers to over 60 important questions about creation, evolution, and the Bible. You won't want to miss it. Now back to the interview.
Can you just explain uniformitarian a bit more? It's something I haven't heard much about.
Yeah, well, it is a big word, isn't it? And it comes from, it's a philosophy. It's a nickname that's been given to a philosophy. And it's connected with geology in that geologists, of course, observe the rocks which are in the present. We see them now, and we can make observations now, same way that we can observe the tops of the ice cores. We can count the layers in the ice cores which are stored in the freezing department. So we can make those countings of things. And so that's what we can see, but we can't actually go back and observe what happened when they formed. We didn't see it form. That's the problem. And that's always been the problem with geology. And the question is, how do we get around that? And the uniformitarian philosophy is that we can observe the present. So if we can observe the present, let's assume that what happened in the past is the same as what happens in the present. It sounds reasonable, but there's one big thing is that they do not believe in Noah's flood. So they didn't see that happen. They don't believe it happened. And as a consequence, the answers they come up with are way different from what a creationist geologist comes up with.
Thanks. That makes a lot more sense. So you're talking before about the top 1,000 meters, not 1,000 meters.
It was 1,000
meters. That's
yeah.
right. The top 1,000 meters, and then you're saying the 2,000 meters below that, that's where there's a bit of difference in opinion.
That's right. And that's because, well, there's a couple of reasons. One is because the layers are not so clear as you go down as the layers. And the other reason is they're based on their assumptions, they're based on their modeling as to what's happening down there. Again, since we didn't see it happen, the uniformitarians come up with a model. How are they going to explain and interpret the ice cores which they've dug out? And so what they do is they build a model of this ice sheet, which extends for hundreds, thousands of kilometres across Greenland, and it's these 3,000 metres thick. How do we explain it? So they've got this model, and they assume that as it snows, the snow builds up on the top of it, and then with time it gradually squishes down, and as you go down towards the bottom, the layers get closer and closer and closer together until they're almost like just thin sheets of paper. And so that's how they can count so many layers right down in the bottom, is because of their assumptions about how the ice core formed. And so basically they're starting with what they wanting to come up with, which is what happened. And if you have a different sort of starting assumption, then you come up with a different answer. And that's what creationists do. They have a different way of explaining things.
So the ages you're saying that they give are based on assumptions about those layers being squished down together. And
about them being squished down together and being very, very close together. And of course, they then have to decide how many of those layers form 1 year. So there's a lot of subjectivity about that. And so it's the numbers that they come up with. Most people hear the number and think that it must be true, not realizing how many speculative assumptions are built into doing the calculation.
Yeah, so it doesn't sound particularly convincing with the Greenland ice cores. What about the Antarctic ice cores?
Well, that's even more interesting because there are no layers at all that they can count in the Antarctic ones. And they drill sort of similar sorts of lengths, 2,000 meters, 3,000 meters, some sort of lengths like that. And so how are they going to calculate an age from that? And so it's interesting that they come up with much bigger numbers. So in the Antarctica, they come up with dates for one of the ice cores of 800,000 years.
Wow.
And there's no layers. When you think about it, you think, well, how do they count 800,000 layers of ice. How do they count that? Can you imagine sort of counting, a ream of paper, which is 500 sheets in it, and it would take quite a while to count that, although I guess bank tellers are pretty good at being able to count lots of money. But the idea is that they think they counted these layers, but there are no layers there. So how do they do it? And they come up with a theory it's called the astronomical theory of ice ages, and it's another name that's given to it is the Milankovitch theory. And it sounds a very impressive name, big name, lots of letters in it, so it sounds like it must be true. And so it comes up with this theory, and that's how they work out or come up with a number for the age of these ice cores.
Right. Well, can you talk a bit more about those cycles? And you said that's to do with the ice age, is it?
That's right. When the first guy, Louis Agassiz, came up with the evidence and put it forward that there was a lot more ice in the past, when he came up with this, the scientists at the time didn't believe. They thought, that's ridiculous. How in the world could you get a lot more ice? And they were thinking that you have to cool the Earth. How could you possibly cool the Earth? And so those are the ways that the speculations came on, and there was a lot of resistance to it beginning with. But in the early 1900s, there was a guy called Milankovitch, obviously, and he came up with this astronomical theory that it was changes in the Earth's orbit, the Earth's orbital parameters. So, for example, you've got the orbit of the Earth. If it goes longer or more circular, that affects the amount of sunlight on the Earth. Or if the angle of the inclination of the Earth's axis is different, that he built that in. And then if the Earth's axis precesses, then that affects it as well. So he's built all these different factors into his. It's a big calculation. It wouldn't have been computers to start with, but they do it on computers now. And so based on that, he was able to figure out that the Earth could be hotter and cooler at different times in the past, at different cycles. Like for the orbit of the Earth, it's 100,000 years. That's the timing there. And then there's another one to do with the inclination of the axis, which is about 50,000 years. And then there's another one about 26,000 years. So based on these cycles, he was able to come up with a way of predicting the ice age that came about. But it had big problems. First of all, just changes in the Earth's orbit doesn't produce enough change in temperature. And so that was a problem. And then what happened is people introduced another parameters to sort of exaggerate and to amplify the changes. And that created a positive feedback mechanism. You know what a positive feedback mechanism is?
I think I've done a bit at my church. We do a bit of sound desk work at the back. And I know when you hold a microphone, someone's talking on it, and it's a bit too close to a speaker, the sound just goes up and it blows up, and you get this whiny noise that's really
huge
loud.
Noise, isn't it? It just goes crazy. That's exactly right. Until you turn the amplification down or take it further away from the speaker. Well, that is the idea, is that what is happening on our Earth is a positive feedback mechanism in order to get enough temperature change to be able to have a ghost of a chance of being able to predict the ice age's work.
Right.
And it's interesting that everything on Earth is stable. When things change, they tend to come back to equilibrium. And in so many ways, it's like that. And yet they've got this obsession these days with the Earth's climate being unstable. And that's why they say, we've only got, so many years left to go before the whole thing falls off a cliff. And it all comes back from the models that have been produced by this Milankovitch cycle to be able to explain an ice age. And so that's the way they interpret the ice cores, is by using Milankovitch. And it really doesn't work.
So you don't think the Milankovitch cycles really fit the data? They're not.
Well, does the Milankovitch fit the data, or does the data fit Milankovitch? Well, you can make it fit anything. I don't know. When we do engineering, we used to be able to analyze all sorts of different mathematical functions, and you'd use what we call Fourier analysis.
Yes.
And so you'd use different wavelengths, And from these different wavelengths, you could combine a few of them together and you could make it into any shape. It's remarkable. And that's what I think is happening with Milankovitch. They've got these 3 different wavelengths, and by combining them in different ways, you can get them to fit almost anything. And that's what I think they're doing with the ice cores. And it sounds impressive. And that's what they're doing in Antarctica, is they can't count the layers, and so they're picking other parameters which are within the ice core, and based on these, they're fitting them to Milankovitch cycles, and they call them this astronomical cycles. And based on this, they've come up with an age of 800,000 years. So it sounds to me like they've got this 100,000 year period for the orbit of the Earth, and they've been able to sort of fit it in somehow and find some parameter that's varied 8 times in this whole ice core, and based on that, they've 800,000 years. So
and there it is.
I don't think it fits at all. As a matter of fact, it wouldn't work for creationists because the creationist time frame is much, much shorter. Creation, some 6,000 years ago.
Yeah.
So it's only a very short time. You're not going to fit even a quarter of the shortest cycle of Milankovitch into the whole of the creationist timescale.
Do we have any other data that provides more insight into ice core dating?
Well, when you think about the thickness of these ice sheets, and they're talking about, these hundreds of thousands of years to build up the ice sheets, as a matter of fact, even the uniformitarian glaciologists, they recognize that you can build up an ice sheet very quickly. All you need is sufficient accumulation of ice. And you can get various parts of the world where there's incredible accumulations which occur. There's places in, the northern hemisphere up near Japan where you get in a snowstorm or in one winter, incredible accumulations of ice. So there's no problem at all with building it up. And as a matter of fact, the creationists look to an event which is Noah's flood. I don't think we've talked about that, have we? About Noah's flood and the...
Not in detail, yeah.
We'll get onto that in a little bit later. We'll explain about the effects of that. But there is one amazing thing which happened during World War II. And it involved a heap of aeroplanes, a squadron of planes which were flying over Greenland, and they got caught in a storm and they all had to ditch in the storm. And so there were a number of fighter bombers, and there are a number of very large bombers which were caught, and they landed. Fortunately, the good news is that all the people involved were rescued and taken away, and there was no problem with that. But they left the planes there and just abandoned them. It was many years later that there's an airplane enthusiast who sort of buys and sells planes, and he's got an airplane museum. He came up with the idea, hey, wouldn't it be great to go and recover these planes which are just sitting on the top of the ice in Greenland, and we can get some amazing planes. So they went there to try to look for it. They went on this expedition, and they couldn't find them anywhere. And so it was an 11-year sort of period where he was searching for these things, and eventually they used sonar to detect down below. The amazing thing is that when these guys, they actually found these planes, they found this squadron under the ice. They discovered it was 75 meters under the ice, and it had moved sideways something like about 1.6 kilometers.
Wow.
So 1.6 kilometers doesn't sound a lot, excepting if you're using sonar and that to detect things, you're moving around a long way to try to find these things. So they found them, and then they decided how they're going to retrieve them, and they had quite an elaborate program of being able to use hot water to make a tunnel, to make a shaft going down into the ice. And one of the planes, one of the bombers, the fighter bombers had lost its wings, and they were able to recover that. They were able to recover the fighter and bring it to the surface. And then amazingly, they restored it, put it back together, and mostly with original parts. They had to make few extra parts to be able to get it together, restored the paint job and flew it, which was quite an amazing thing. And I think you can actually see some pictures of this thing flying when they did it. It was quite an amazing achievement.
So what does that say, though, about the you got all that ice above the plane? What does it say about the rate that ice can build up?
Well, it's a huge build-up compared to what they imagined it was going to be. And the build-up indicates that if we're talking about a 3,000-metre ice core, a 3,000-metre ice core at that rate could build up in less than something like 2,000 years, less than 2,000 years. And so there's oodles of time to be able to fit that into a biblical timescale, even at the current, ice accumulation rates. But then remember that we've got the very rapid rates of accumulation at the beginning of the flood, the Noah's flood, and that's another story.
Yeah. So we've got this evidence saying that the dates of like hundreds of thousands of years in the ice cores that they say, with the layers that they're using, especially in the lower 2,000 meters, isn't very reliable. And then we've got this example of the plane that's been, crashed and then covered in 75 meters of ice over about 50 years. It's all looking like, the ice core dating we have at the moment isn't the best way of looking at the evidence from a secular perspective. Well, what actually does explain the ice core data?
Well, the secular interpretation, as you say, is giving the wrong ages. But when we look at a different interpretation, which is perfectly plausible, you find that it does. For example, from a biblical perspective, where does the ice accumulation begin? It begins after Noah's flood. So when the flood waters had gone down, the waters had receded off the earth. During the flood, there was a lot of volcanic activity, which the waters were warmer at that time, right at the end of the flood, than they are today. And as a consequence, there was a lot more accumulation, a lot more rapid accumulation of ice on the areas of land which were exposed. And so the ice accumulated very rapidly. And so that's how we ended up with the ice cores. So the lower parts of the ice cores are what account for the result of the rapid build-up during the beginning of the Ice Age, and the upper parts, which more or less fit what we see today, and that's where it fits within this uniformitarian philosophy. What we see today is what happened in the top 1,000 meters or so of the ice core. It fits with that, but it's the other part which is different, and that's how the Noah's flood explains the ice cores.
Yeah. So the evidence is looking like the creation perspective actually explains the ice cores a lot better than old ages. I always thought that, old ages were based on observational science. So you're saying that that's actually not the case.
Well, anything about the past can't be observed. And so we can make observations and we can make extrapolations, into the past. But I remember that in our engineering training that we were always warned not to extrapolate, or to be very careful about extrapolating, because things can happen as you extend out, that you can reach a situation which does not fit with what you're measuring. And a lot of amazing and terrible things happen as a result of extrapolation. And that's what's happened with the ice cores. They're extrapolating into this region, thinking that it accumulated slowly, when in actual fact it accumulated rapidly immediately after the flood.
So if people are listening to this and they've got some questions and they're thinking, what I originally thought about these long ages, maybe that's not right, and they may be frustrated, maybe they're a bit angry and they're like, I don't want to change the way I think, or maybe they're challenged and they want to learn more. What advice would you give to these people?
Well, it's very interesting, isn't it, in that we're talking about an ice core. It's a core of ice. And what could sort of affect us as a core of ice? It's the story that's told around this core of ice that affects us. And the story that we hear, 100,000 years, millions of years, this idea of millions of years affects us, our understanding of where we came from. Where did I come from? Why am I here? What's my purpose in life? What should I be aiming at? And by the time we reach sort of at our teens, middle teens, in our 20s and 30s, we've picked up a lot of this information from the things that we've watched, the things that we've learned, the families that we grew up, and we've sort of come to conclusion about that. So when I come along and start talking about, hey, the things that you've heard are not necessarily so, and they're quite different, people can become very upset about that. And I've noticed that sometimes that our comments get a lot of angry comments. And that's because people are challenged inside. I don't want to go there. I don't like this. And I always think, hey, that's a good thing, because what's happening is the things that we thought were true, actually we're being challenged to rethink. And it's sometimes a bit painful to go there because we're not sure just whereabouts it's going to end up. But then there are other people who, who've maybe grown up in church and heard the stuff in the Bible, and they've heard these challenges, and they've been uncomfortable about what they've heard. So when you hear this, what we've talked about the ice cores, they might get a sense of, wow, that's really cool. I'm so glad about that. I'm going to do some more research on it. So I think that's the key for wherever you come from, is to take this as an opportunity. I need to follow this up and find out, if what I've been told and what I've picked up and what I'm believing, if it's not necessarily true, I want to know. And so I think that's the place where you can end up with ice cores. They can really make a big difference in our lives.
So is creation.com a good place to find this information?
It's a great place to find this information, Michael. I've got quite a few articles on there, and I'm very glad about that. I enjoy doing the articles for creation.com. You can find articles on just about anything, and you can find them at an easy level and at an academic level. No matter what you're looking for on creation, of course, you can find it there. So it's a great place.
If you've enjoyed watching this, you're going to want to check out the Creation Answers book, packed with biblical answers to over 60 important questions about creation, evolution, and the Bible. And if you want to get a copy of the free ebook, follow the link in the description.
Thanks, Tas. Great to listen to.
It's good to be here.